here right now, that means that you didn't get problem one correct, but it's okay. We're about to go over it together and find out what misconceptions or issues you had. And don't worry, you have two more opportunities to earn you some extra I'm ready points today in this rotation. All right, so let's look at the problem. Last year, an elephant was born at the zoo. The elephant has gained 381 pounds since birth and now weighs a total of 576 pounds as shown in the model. Which equation can be used to find the number of pounds the elephant weighed at birth? Now, the first thing we want to look at is we're given a model for this problem. Can anyone tell me what type of model this is? If you said a strip diagram, you are correct. So when we're looking at a strip diagram, first we want to notice the top portion um, is our total. So this is the total amount this strip that the diagram represents, and it's you can connect this to what you learned in your previous grade levels of part whole, part, and this is our whole. However, in this particular diagram, we are given two quantities, but one of them is unknown. So we're trying to find out what the unknown quantity is. However, the first thing we're going to do is we're going to go back and look at our problem and dissect any information that we may need. All right, so let's look at it. Last year, an elephant was born at the zoo. The elephant has gained 381 pounds. So first thing I want you to do is let's go ahead and circle this number right here, 381 pounds since birth, and that weighs a total of 576. We're going to go and circle our numbers. 576 pounds is shown in the model. All right, so now we have already circled all the key numbers in this problem. Now we're going to go back and we're going to look again at our question. We're going to go ahead and underline our question. So you can underline it or highlight it. It says, which equation can be used to find the number of pounds this elephant weighed at birth? All right. So if you look at this question carefully, you will notice that it's asking us which equation. So we're trying to find the equation. So we have two quantities. We're trying to find a relationship between them and how they can help us find out our unknown quantity. All right, so now we're going to go back and see if we have any key math action terms that can help find out what operation we'll be looking at when it comes to our equation. So it says last year an elephant was born at the zoo. And don't worry, we may read this several times, but the more you read your problem, it will just help you better understand it. Last year an elephant was born at the zoo. The elephant has gained. Does that word gain stick out to anyone? Good, it should. Because when we see this is actually a math action word. So we're going to box this in right quick. Okay, when you gain something, what does that mean? Are you adding on to something you have, or are you taking away? Yes, you're adding on. So we're going to box that in. I'm going to go ahead and put an addition sign over top of it. So the elephant gained 381 pounds since birth and now weighs a total. And here's another action word, total. And we know the total is the complete sum amount. And when we're dealing with total, we're dealing with what? Subtraction or addition. Correct. We're dealing with addition. So we can already see that our equation is going to have to deal with what? What operation? Addition. Good. All right. So a total of 576 pounds as shown in the model. Now, which equation, we already covered that, can be used to find the number of pounds the elephant weighed at birth? All right. So now we already know that we're dealing with the addition. We're dealing with addition. So we're going to go through and we're going to look at each equation and see which one can actually help us find out what our unknown quantity is. Now, here's a tip. Remember that whatever the sum is when you use this equation, it can never be greater than your total amount. So if you're doing an equation, you're doing your adding your algorithm, and you find out that if you did that, it would be more than your total amount, then we can already X that answer choice out. So let's look at A. It says 576 plus 381 equals. Now, I can look at this off the top of my head and I could tell, like, whoa, 576 plus any number would automatically be what? Greater than what? The total of 576. So question A cannot be the right answer choice. So we can mark that out. All right, so now let's look at B. B says that the unknown quantity plus 381 equals 576, which are total. So we know that the equation has to equal the same total. And we are dealing with what? Addition. So we have our addition. So it's saying if I add the unknown quantity plus 381, then I will come up with my total. Now, we know now one thing I'm gonna so we know if we're dealing with part whole, that means that this part plus this part equals that. So right now it's saying that part plus part of this diagram equals our total, or gives us our sum. Now, if we want to find out exactly what our unknown quantity is, one step we can do is we can do subtraction. So we have 576 as our total. We can subtract it from the given quantity to find out what our unknown quantity is. All right, so let's go ahead and do that right quick. We're going to do a standard algorithm. So if you don't, you should have a piece of paper and you could be working along right with me. Oh, see? I forgot we're doing what? Subtraction. We got to be careful, make sure we're doing the right thing. And they will always give you an answer choice that is close to the right one, but maybe a different, maybe just switched up a little bit. So 576 minus subtracted by 381. All right, so 6 subtracted by 1 is 5 every day. All right, 7 subtracted by 8 is 1. No. Okay, why can't we do 1? Because what? The top of our number is greater than the number at the bottom. So we will have to borrow from the 5 to fix this. So we're going to borrow, take 1 from 5. 5 minus 1 is going to be 4 every day, twice on Sunday. And now we're going to take that 1 that we borrowed and put it in front of our 7, and we have 17. So now let's do it. 17 subtracted by 8 is, we can do this, 9. Good job. All right, now 4 subtracted by 3 is what? 1. So this is telling us that our unknown quantity is actually 195. Now, what we can do is we can plug in what we just found out as our unknown quantity and see if we use it in this equation, if we will come out with the same solution, the same sum or solution. All right, so let's do that right quick. And one thing about with subtraction and addition, they're brothers, twins, whatever. You know, you can do the inverse or do the opposite of the two to find each other. All right, so we're going to do 381 plus 195, I said, and it should come up with what? 576. If this is correct, then we have already found our the right equation. All right, so 1 plus 5 is 6. Good job. 8 plus 9, 17. One quick way I do it, I know 8 plus 8 is 16. Then I have one more carry because of 9. That gives me 17. So it's 17. So we're going to bring down our 7, carry out 1. Now 3 plus 1 is 4, plus the one that we had to carry give us what? 5. So did we get the correct solution? 576. Is that what we're looking for? Correcto mundo. So we have found our equation, the correct equation. And let's just look at C. C says unknown quantity plus 195 equals 381. See, you see what they did, how they tried to trick you. 195 is what? What we came up is the actual unknown quantity plus equals 381. So it's saying that if I do an unknown quantity plus 195, I get 381. But I know that the sum we are trying to get is what? 576, correct. All right, let's look at D. 576 plus 195. Again, remember, our answer cannot be greater than the total. And 576 plus 195 will be greater than 576. So B would have been your correct answer. All right, good job. Thank you for working with me. We're going to go on to our next problem.